Hi everyone, today we're talking about topic 3.2, properties of solids. So these are the four different kinds of solids that we're typically going to encounter in AP chemistry: ionic solids, covalent network solids, molecular solids, and metallic solids. So the first type of solids we're going to talk about today are ionic solids. These are held together by ionic bonds. They form a lattice structure. What I mean by lattice is is shown here on the right. And so you'll kind of have a bond here, a bond here, a bond here, here, kind of like a cube, and they're stacked on top of each other. And so you'll have kind of this little grid here, and then another grid followed by another grid, or you can kind of see it through a slice, right? You have these regularly ordered chloride anions, and then within them, you have regularly ordered sodium cations. And so that's what I mean by a lattice structure, held together by electrostatic interactions. Right, and what I mean by that is that it's described by Coulomb's law. Right, and so all the properties of Coulomb's law apply to ionic solids. And so if you're trying to think about the strength of an ionic solid, think about Coulomb's law. They have high melting points, high boiling points, and they will conduct electricity when dissolved or melted. Right, so an example of these would be like sodium chloride, right, sodium iodide, sodium bromide, really any kind of ionic compound. The second kind of solids are covalent network solids, and so these again are a lattice structure. But they're held together by covalent bonds. Right, so ionic solids are held together by ionic bonds. These are held together by covalent bonds. They're extremely strong. Right, covalent bonds are generally pretty strong bonds, and so covalent network solids are also extremely strong. Things like diamonds are covalent network solids. They're typically formed by nonmetals. So think carbon, silicon, boron, germanium, Ge, right? All those things kind of towards the right part of the periodic table, not all the way to the right, but kind of near the metalloids, carbon, silicon, boron, all of those. Those will typically form covalent network solids. These, again, have a high melting point, high boiling point, and they do not conduct electricity. Which makes sense, right? We don't have ionic bonds, we have no ions, we have no charges. It should not conduct electricity. The third are molecular solids. And so molecular solids are covalently bonded molecules, but they're held together by intermolecular forces, right? IMFs, which we learned in our 3.1 video, right? And so if you take iodine, for example, right, these are covalently bonded to each other, but they're attracted to each other by IMFs, right? Whatever, you can think back to all of our IMFs. They're attracted to each other by IMFs, and so this kind of makes a solid. These are generally very brittle, right? They're weak. They're not made of any actual bonds. They have low melting points as a result, and they also have low boiling points as a result. And again, they do not conduct electricity because they are not charged. Last, we have our metallic solids. These are positively charged ions surrounded by a sea of electrons. Right, and so you'll have these positive ions, whatever it may be, some sort of a metal, and then you'll have electrons kind of scattered throughout that jump around between each of those ions. These are malleable, meaning that you can pound them pretty flat easily. They're ductile, which means you can pull it into a wire easily. They have a high melting point and a high, well, they pretty much don't boil. So I'm going to erase that. And they conduct electricity. Right, because it's a sea of electrons, there's a bunch of charges moving around, these conduct electricity. And these examples of these are, for example, your pure metals. So think zinc, copper, right, platinum, things like that. That's all for today. Thanks, guys.